Hello everyone. I hope you guys are doing well. So I just wanted to create a resource for us to get back to in organic chemistry. If you need any help, if you feel like you forgot the concepts, if you are currently struggling, if when you get back the quiz grade in a couple of days, you feel like, man, I thought I'm gonna do better. This would be a good resource for you. Of course, this in addition to after school, in addition to class time and so on and so forth. So don't just depend on a video, but this is meant to supplement your studying. This is meant to supplement your review. And as we transition into different units and into different topics, of course, it's natural to forget a couple of concepts. So this would be a good video to get back to if you want to remember your concepts. And I'm gonna start sharing the whiteboard because it takes forever to load. And until it loads, I do want to say that, like, actually, for me as a student, I never ever spent time memorizing organic chemistry rules. I never actually had to sit down and remember, oh yeah, carboxylic acid is oic acid and like esters is O8. I never had to do that because I practiced so much. I know you guys are gonna say that I'm such a nerd, but I used to actually do organic chemistry questions before I go to bed for fun, as if they're a puzzle. This was where I was. So, like, practice is what helps you memorize those rules. So if you find that you're struggling with memorization, hey, don't sit down and try to memorize. Practice. Practice with your notes for a little bit, practice without your notes for a little bit. And you're gonna find that this is gonna get way easier and actually a little bit fun, I think. I love organic chemistry, so you guys, I might be a little crazy, but I just absolutely love organic chemistry. Anyway, so the whiteboard is loaded. Now, I will go over the general rules for nomenclature. I'll go over priority in this video. I will not do examples since we do a lot of examples in class, but I do want to go over just the basic rules so we could have them with us until the end of the semester. Okay. So first thing I want to go over is the numbering system. So one, and try to say it as I type it up, just to help you like consolidate those memories. So one carbon is meth, two carbon is eth, three carbons is prop, four carbons is bute, five carbons is pent, six carbons is hex, seven is hept, oops, is hept, eight is oct, nine is known, 10 is dec. Okay. And I will never give you longer than a 10 carbon chain. Alrighty, so those are the numbering systems. Now, I also want to say that alkanes, which are single bonds, so alkanes, which are single bonds, their ending is an, and that comes from the word alkane. Okay? Alkenes, which are double bonds, which like are chains that have double bonds, they have en. And sorry, the lighting system is bad here. Wow. And alkynes, which are triple bonds, is yn. Okay. And I forgot the K right there. Alrighty. And the last thing is branches and in YL. So those are the basics for the alkanes. Now, and this is the part where honestly, trust me, practice makes perfect. Practice makes perfect for those. So carboxylic acid. Remember carboxylic acid, its structure is C double bond O, OH, OH, and I'm gonna draw my cut. And I guess no one's gonna ask me, Miss, what's a cut again? Just because I explained it so many times, but a cut means that it is bonded to another carbon. It is bonded to another carbon, not a hydrogen. It's bonded to another carbon. So this is called a carboxylic acid. And it ends with and this is the famous one. I think all of you should know it. It ends with oic acid. Okay. Is it ever a branch? It's never a branch. And when we go to priorities, you're going to see that even more. But carboxylic acids, they are never branches because they are always the highest priority. Now, carboxylic acid has a very sweet cousin. Its very sweet cousin, her name is Esther. Okay? Her name is Esther. Now, the difference between carboxylic acid and ester is that the ester is bonded to a carbon at this oxygen right here. It's bonded to a carbon rather than a hydrogen, a carbon chain. So the ending of an ester, so ester loves eating. Ester absolutely loves eating. So ester O8. Okay. Now there's like a much more extensive naming system for esters, and I'm gonna go over an example just for the esters. But let me just finish off the list, and then the ones that need examples, I'm gonna do them. Now, ester has a sibling that also looks very similar to it. That is the amide. That is the amide. So now, the amide, because a lot of you, for some reason, got confused about that on the quiz. An amide, it could have NH2 over here. That's called a primary amide. It's only bonded to a carbon, one carbon. Now, a secondary amide, so that's going to be primary. A secondary amide is pretty much the same. I'm going to see if I could copy it just to avoid wasting a lot of time drawing. So it's pretty much the same, except instead of having a second hydrogen right there, instead of it, it has another carbon. Now, the way that I would personally draw this is I would put the hydrogen on a bond by itself, and I'd then connect it to a carbon right here. That's a secondary amide. So secondary. And a tertiary, obviously, we remove the third hydrogen and we add another carbon. So a lot of you, like not most of you, asked me about this on the exam. So make sure you are aware of that. So this is called an amide. Now, if an amide is the highest priority functional group, it ends in amide. Very simple, very straightforward. If it's not the main priority, if it's not the main chain, it like we put it as a branch, as if it's a branch, and it's a carbamoyl, carbamoyl, carbamoyl group. Okay. So that is for the amide. Now, we then have other other functional groups that only have one oxygen, and the rest is either hydrogens and carbons. So we've got over here the aldehyde. The aldehyde, the difference between a carboxylic acid and an aldehyde is that it doesn't have that second oxygen. So anytime I'm looking at a big molecule, how do I know the difference? If at any time, guys, you see two oxygens right beside each other, just immediately think, oh, is it a carboxylic acid or an ester? Those are the only two that have two oxygens. Okay? If it doesn't have two oxygens, it's going to be either an aldehyde or a ketone. So that should be your thinking strategy. So again, make it easier for yourself. Make those shortcuts to make it easier for yourself. So this is called an aldehyde. This is called an aldehyde. If the aldehyde is the main group, it ends in Al if it's the highest priority. If it is not the highest priority, we put it as a branch and we call it a formal. Okay? And by the way, while I'm drawing them in order of priority. So that you guys don't get confused. So now, an aldehyde has a really nice cousin too. Its cousin is the ketone. The only difference between an aldehyde and a ketone is the same difference between an ester carboxylic acid. We just removed that hydrogen on the side. So, and I forgot to put cuts here, guys. I'm just gonna put them so we stay consistent. So this is called a ketone. A ketone, if it is the main functional group, a ketone, it's going to end in "-one" or one. If it is not the main functional group, if it is a branch, then I'm going to put it as oxo, as oxo. Okay? And by the way, aldehyde, it's aldehyde, so it ends in AL. Just again, a way for you to remember it. Now, the last three things that we have, we've got and they're all also cousins. So we've got the alcohol, we've got the amine, got the amine. And again, the amine could be primary, secondary, tertiary. Always remember that with amines, you could always have primary, secondary, tertiary. So do not get confused if you see either. And then we've got the ether. And we're gonna just put all of our cuts, all of our scissors. Okay, so an alcohol, hol, H-O-L. So it's gonna end in O-L. So an alcohol, it ends in O-L. If it is not the main functional group, it's gonna be hydroxy. Which kind of makes sense, right? An amine, an amine, as the same way that we had with the amide, it ended in amide. With the amine, it will end in amine. And if it's the main functional group, remember, it's amine. If it's, sorry, not the main functional group, it's going to be amino. Amino. And that should ring a bell for you, for those of you who are taking biology. Amino acids. Amino acids, they have an amine group and they have a carboxylic acid, and that's why they are called amino acids. Amino from the amine, acid comes from carboxylic acid. So it all ties in together. By the way, biochemistry and organic chemistry, they're very, very intertwined, especially when you start taking university level biochemistry and organic chemistry. And lastly, ethers. Ethers, they have a special way of naming, so they are usually not the main functional group, and even if they are, it's gonna be oxy, and it's always gonna be in the middle. So oxy, and then maybe we could do an example of the ether to clarify that too. So now this is again arranged in order of priority. Notice the trend. So notice that the greater the number of oxygens that I have and the greater the number of hydrogens, the higher the priority. So bear that in mind. So again, you want to avoid memorizing as much as possible. You want to understand the reason. So I'm telling you, the greater the number of oxygens, the greater the number of hydrogens, the higher the priority. And ester and amide, they are on the same level pretty much, right after each other. And an alcohol and an amine, they are right after each other as well. So this should all, the picture should be coming together. Now, I do want to do an example of naming esters, an example of naming ethers, and esters, they're pretty much the same as amides. So I shouldn't have to dive deep into those. So naming esters. So let's say I gave you this ester right here. Let's say I gave you this ester over here. Okay. Now the ester is subdivided into a section that's after the oxygen right here, the ester oxygen, and a section that's before the carbonyl. And remember, we mentioned that this group right here is called the carbonyl. So whatever is before the carbonyl is a section, and whatever is after the oxygen is a section. Okay? Now, always, 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 whatever is after the oxygen, we identify it as a branch. It's a branch. So in this case, I've got 1, 2, 3, 3. 3 was prop, and a branch I put propyl. Now, how do I know that it's bonded to the oxygen and not any other carbon? Is that I say O, so O propyl, and then I continue. So I continue, I number the chain 1, 2, 3, 4, 5, 6. So that's gonna be hex. And then I ask myself, do I have any double or triple bonds? No. So it's gonna be, oops. No, what's happening? Wait, guys. So I do not have any double or triple bonds. So it's gonna be hexane. And then the main functional group in this case is the esters. It's gonna be O8. Hexanoate. Okay? So O-propyl hexanoate. I hope that makes sense. With the ether, with the ether, it's slightly different in that with the ethers, the longest chain, so we have two chains on the sides of the oxygens. So the longest of them is gonna be the main group, and the shorter one is gonna be the branch group. So I've got 1, 2, 3, 4. That's the shorter one, so that's gonna be butyl. And then I'm gonna have butyl, butoxy, pentane. Now notice that over here, I didn't write butyl, even though I treat it as a branch. And this is one of those exceptions. Even though I treat it as a branch, it's butoxypentane. Okay, because I've got this ether right here. Alrighty. Amides, they're pretty much same as esters, except that instead of the O, I'm gonna put an N. Okay. Now, the last thing I want to sprint through, just because I don't want this video to be too long, is the cyclical chains and the cis and trans, just because I know a few of you were confused about that as well. So remember we had this function group right here. 2, 3, 4. Oh, there you go. So 1, 2. Remember what that was called? That group right here is called a benzene group. A benzene group. Now, if it is the main chain, if it's the main chain, if it's the highest priority, and I'll tell you when it is the highest priority. If it's the highest priority, it's benzene. The name ends in benzene. If it's not the highest priority, if it's not the highest priority, the name is going to have a branch called phenyl. Now, notice that even though benzene has double bonds, I do not indicate those double bonds because they are inherently part of the compound. They're part of the functional group. So I don't necessarily indicate, oh, it's at position 1, at position 1, 2, 3, at position 3, at position 5, I've got double bonds. We don't do that with benzenes because the double bond is inherently part of the functional group. So like when we say benzene, all of us know, oh yeah, it's that structure, the ring structure with those double bonds and those positions. Okay. When is it the highest priority? Benzene is the highest priority when it doesn't have, it's not attached to a branched chain. So this, if it's only attached to this chain, it would be the highest priority. Okay. But at the moment that I make this chain a branched chain, in that exact moment, benzene is no longer the highest priority. Benzene becomes a branch. Okay. And I know some of you are looking at the structure and you're wondering, oh my goodness, how am I going to name this structure? I will not give a structure like that to you. I'll be putting it at the first carbon. So maybe it will look something like this. Something like that. And it would have a couple of branches over here. Maybe it would have an isopropyl right here. Something along those lines. So the moment that you start to have a benzene attached to a freaky looking structure with branches, you know that benzene is not the highest priority. Likewise, if I've got a double bond in the main chain or in the backbone, benzene is not the highest priority, even though it has more double bonds. But it's just that in the naming, we want to have that double bond included in the main chain. Okay? So when is it the main functional group? In a structure that looks like this. So if I have a benzene ring, and I'm just going to draw the circle for time's sake, and maybe I've got a methyl here, I've got an ethyl here, I've got a dimethyl over here, and maybe I've got a chlorine here. In this case, the phenyl group is your main functional group. the structure, I'd start naming at the highest priority. And remember, alkynes, alkenes, alkanes, halogens. That's the priority order for the stuff other than functional groups. So alkynes, triple bonds, alkenes, double bonds, alkanes, single bonds, and the last of them is the halogens. So in this case, I'd start numbering at the longer carbon chains. I'm going to have one, and then I want the lowest numbering for the rest of the system. So I'm just going to have one, two, three, four, and five. So then this structure would be called, and I'm just going to say it verbally, it would be called 3-chloro, 1-ethyl, 2,4,4 trimethyl benzene. Okay. So this is when it would be considered the main structure. Alrighty? Now, with cyclic rings, anything that doesn't have a benzene structure is a cyclic ring. Like even if I have a six-membered ring, but it doesn't have those double bonds, this is a cyclic ring. Okay, so in this case, this structure would be called a cyclohexane. I just put the word cyclo before it. So anytime I see a cyclical structure, I'll just put the word cyclo before it. Whether it's a branch, whether it's a main group, whether it's the backbone, doesn't matter. I'll just put the word cyclo before it. Cyclohexyl if it's a branch, cyclohexane if it's the main functional group. Okay. Now the last thing I want to go over is cis and trans, just so we could have it also on record. So cis and trans. Now, cis and trans, honestly, the trick is knowing your priorities. Knowing which group has high priority, that's going to make life way easier for you. Alrighty, almost done, guys. So, cis and trans, it only applies to double bonds. So it does not apply to anything but double bonds. Now, the way that we identify cis and trans is we take each side of the double bond. So I'm going to split the double bond into two halves. I take the right side by itself. I analyze the left side by itself. So if I look at the right side, I want to identify which group is the highest priority. So in this case, is a ketone a higher priority than an alkane, or is it lower? Take a moment to think about it. Answer it in your head. Ketone is definitely the highest priority. So I'm going to put a 1 on the ketone. And this makes my other group a 2. Okay. And then I'm going to do the same to the left side. I'm going to do the same to the left side. Is it an aldehyde or a methyl group? Obviously, it's going to be the aldehyde. I'm going to put 1 on the aldehyde, 2 on the methyl group. Now, look at that. The ones are on opposite sides. The moment that you see the ones on opposite sides, you know that this is a trans structure. So trans is opposite. Now, if I want to switch this to be a cis structure, let's say I was giving you the name and I asked you to draw from the name. If I want to switch this to be a cis structure, I could do it in two ways. Either I change the left side or I change the right side. It doesn't really matter. Whichever one you want, but never change both, because if you change both, we practically didn't do anything. So either I make it so that the aldehyde is at the bottom. Now the ketone and the aldehyde, they're both on the same side, so that's going to be cis. Or I switch the longer, like on the right side, I switch the ketone and the alkane, and that would still work. In both cases, that would be considered cis. Okay. Now, before I close up this video, I just want to stress something because I noticed a lot of people also get this confused. Guys, in naming, how do I arrange names? I start off with branches, the branch. Now, anything that's present in my name, unless it's at the first carbon, and I'm talking about carboxylic acid and aldehyde only, literally. So unless it's a carboxylic acid and aldehyde, I need to state its location. I have to state its location. I have to state where it is in my chain. So anytime I write a branch, I expect to see a number before it. So I'm going to write number and then branches. So we don't forget that. So anytime I'm talking about any group but the carboxylic acid and aldehyde, I have to write its location. So I have to write a number before it. Now the structure is number dash branch, and then you'd probably have a number here somewhere, again, unless it's a carboxylic acid or an aldehyde. But to skip that part, you will then have the backbone chain and the ending. Now, again. Oh, I forgot actually. So then you need to state single, double, or triple, and then you'd have the ending. Um, mm, 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 mm. Does that make sense? So I write the numbering, I write the branch, I set up the backbone chain, I state whether it's single, double, or triple, and then I state the ending. Before every single one of those, I have to write the location. I have to write the location. Very important. Okay, that's pretty much it. I'll zoom out just in case you guys want to take a screenshot of this, but it's pretty tiny. I don't know if you'll be able to take a screenshot, but there you go. Let's zoom a teeny tiny bit more in. I'll just, uh, 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 uh. Okay, I cannot do any more than that. So again, very important, practice, not memorization. Practice, not memorization. All right, guys. I hope this was helpful. If you have any questions, please, of course, let me know. As always, come by after school. I'll be hosting for a couple of weeks. I'll be hosting online after school on Sundays. So feel free to come to that as well. If you want to come to that, let me know. I'll send you the Zoom link. And of course, we've got Monday, Tuesday. I'm also staying for after school in the school. Alrighty, guys. Take care. And yeah, have fun.